morning. Looks like this works. Are we already live? Okay, so.
Good morning.
Good morning. Welcome. How was the party yesterday? Was it good? Raise your hand. Who is still asleep? Everybody. Okay, I will try to wake you up. So, my name is Marek. This is Jirka. And we are going to tell you something about OpenShift today. But before we start, I would love to get some basic idea who is in my audience. So first, who is an engineer developer? The people who build cool stuff. Raise your hand. Okay, most of you. Who is operations? Those are the people who run the cool stuff. And how many managers? Those are the people who slow down the other two groups. Almost no one. Okay, good. So thanks for the information. The idea is to speak to you about OpenShift for developers, engineers. So I have mostly engineers here, so that's fine. Let's move a bit, and let's describe what is the common problem that we face. This is my favorite slide that describes what OpenShift does. On the left side, you see what it does for developers. On the right side, you see what it does for operations. However, I will just focus on the left side, where we have self-service. So if I'm an engineer, I want to have easy way to give myself an environment to run my application. I want to be able to do something like git push, so I want automation. I want to be able to easily run application in Java, run application in Python, do applications in Ruby. That means I want to be polyglot, multi-language platform. And I want to have one platform for everyone. Even better if I could have one thing that will be the same as for production environments as well as testing. So I don't get into it worked on my laptop problem. So if I have something that resembles as much as possible the production environment, it would be good. So this is one of the basic ideas that we are trying to build. And what we do for that, and you see it in the title, I mentioned Kubernetes and OpenShift. So what's the relation between these two things? OpenShift is actually Kubernetes. It's a distribution of Kubernetes that we do for environments that are demanding for enterprise customers, even for not normal people, that's a wrong term, but for people. And we essentially take Kubernetes, we made it a distribution, we harden it, we do testing, we do verifications, and on top of that, we build a developer experience. Because who tried Kubernetes already? Okay, so from 40 engineers, who enjoyed using Kubernetes? Okay, almost no one. Because Kubernetes is a tool for operations. It's not a tool for engineers. It helps you with running containers. It helps you to be in production. It helps you to make your applications resilient, highly available, etc., etc. But that's not the problem for the engineers. This is the problem for the operations. So if you want to use Kubernetes as a developer, you need some other tooling. You want to build your container using the platform. You don't want to write Docker files. You want to be able to easily see how my application behaves in that container. I want to be easily accessible to metrics. I want to see what is the amount of memory my application is using. Do I have a memory leak? Can I see the logs of my application? Or maybe if I have microservices, can I see aggregation of logs between different services, etc., etc. So Kubernetes itself is great, but it's for operations. So that's one of the things that we do in OpenShift. We build edit things on top of Kubernetes that provide you the developer experience for engineers. But before we move there, we need to understand what Linux containers are. So who tried Docker? Okay, who tried Rocket? Okay, almost no one. Good. It doesn't matter really. So Docker is the most popular nowadays, but the idea behind that is the same. If I have a VM, I essentially have virtual hardware, then I run my operating system on that. My application is in that operating system, right? So I have a kernel, and inside each VM, and each VM is completely isolated from each other. Easy. Everyone understands that. It has been here for years. But with containers, I have some hardware, I have my operating system, and I am not virtualizing the hardware to run multiple operating systems. I am virtualizing the operating system to run multiple applications in isolated environments inside the same operating system. That means I simply spin up my application, and I put some kernel thingies around it to make it isolated from each other, so they cannot interfere, they cannot see each other. I am in some special environment. So what is the benefit? Spinning a container takes milliseconds compared to seconds with VMs, because I don't have to boot the whole virtual machine. The only thing I have to do is to create a process and then isolate it. With VMs, I need to create the hardware, then I need to spin up the operating system, then I can spin up my application. So the boot time from like starting to having the application running is longer. On the other hand, hardware still has slightly better isolation, especially in multi-tenant environments. If you are providing something like a platform for customers you don't trust, then virtual machines may be slightly more secure. But still, containers and Docker and all the stuff that we do is still very good, and you can use it for production environments as well. So now if we understand the sorry. Now that we understand what containers are, so what happens if you run OpenShift is you deploy something called masters. That's where the brain is. That's where all the scheduling is happening. And then you have nodes. And the nodes is where your containers run. So it's easy. You have nodes, you run containers. You have masters, that's where the scheduling happens. And then you have some edit features around that are important. So you have registry. So registry caches your images. When you build a new container image, it will be not pushed to Docker Hub or some other public registry. It stays in the platform, so it's private. So you don't publish everything that you do. Persistent storage. Who can do like 12-factor applications, cloud-native applications? Who does that like normal thing at work? Okay. Who has to deal with legacy applications using persistent storage, stateful applications, etc.? Okay, most of you. So by default, Kubernetes has been conceived to run stateless applications, those cloud-native, 12-factor, whatever you want to call it, essentially the same. But what we try to do is we try to provide an environment that would also allow to run stateful applications using persistent storage, running databases, and this kind of stuff inside the platform in an easy way. So that's other thing. Service layer allows you to somehow map things inside the cluster for communication between different containers. We will get to that in a slide, I think the next slide actually. And then there is a routing layer. This is the slide after the next one. So I will get to that right away. So now I'm getting to how engineers can actually benefit from using Kubernetes, from using OpenShift. This is the basic things. And networking. This is the thing, oh, I am not working with that. I am an engineer, I just develop my code, and this is operations problem. Well, in most cases, yes. But you can actually benefit from some things that the platform can offer you, and it's actually network related. So before we move to that, there is a basic concept called pod and service. So pod is a set of containers. That's just an abstraction of a container. You can think of a pod as a container, just to simplify things. And then you have a service. Service is a load balancing proxy. If you are deploying a container inside Kubernetes, you should never communicate from a pod to a pod unless you have a very important reason to do that. If you do communicate between different pods, you should go to the service. Because the pod, whenever pod is started, it is assigned a new IP address. Whenever pod is started, it changes its identity. When container crashes, new container is started. Complete new identity, complete new container. So my application, if I'm communicating between different containers, I have to know what is going to be the IP address of the next container. I have to do some discovery. I have to do something to figure out where I should connect. If my database failed and I need to reconnect, I have to have the new identity of the new container. So with service, I simply say I am always going to this service, and the service hides all this complexity for me. It is a proxy that always reconfigures itself to send the request, the connections to the correct pod behind that. So I always connect to service that's stable. Its name, it can be either the IP address, or you can use DNS-based discovery. So essentially, the service name is always resolvable to the IP address of the service. So I can simply deploy MySQL, call the service MySQL, and in my host name, I will just say hostname MySQL. and it will always resolve to the correct IP address of the pod of the container running somewhere in the platform. And I don't really care where and how it is done. The platform hides all this complexity from me. So that's one of the things. The other thing is, whatever you deploy inside the platform is internal. So if I spin up a new container inside the platform, it is not going to be accessible from outside. I need to create some entry point to be able to communicate with the service running inside the platform. And for that, there is a router. In Kubernetes, it is called Ingress. The problem is we needed something like Ingress way before Kubernetes decided they want to have Ingress. So we had implemented routes inside OpenShift. Now we are upstreaming everything into Ingress with the goal to actually move to Ingress eventually. But like this was the evolution, why there are two different concepts. And so everything that runs inside the platform is isolated from the outside world. And you have to create this kind of route or ingress that will allow you to access it. This is just the basics that we need to understand. And the last thing is the SDN. So SDN is the networking configuration that says how my pods, how my containers inside the network can communicate with each other. I have different ways how to configure that, and I don't want to go into the details. But if I do the basic one, it says every project, which is essentially a namespace in Kubernetes, has its own VXLAN. So whatever I deploy in one project is not accessible from other from containers in other projects. So everything is isolated inside that project. How, as a developer, can benefit from that? Let's say I'm developing an application, and the application needs to be sure that the communication is always accessible only through some specific points, right? And if I'm deploying it on my local network, I can communicate from wherever I want to wherever I want. So sometimes it happens to me, I don't figure out that the communication was going through some other route than I was expecting through some entry point to my system, right? So if I do that, and I know that I always can isolate my services inside the projects, I know that the only way how to communicate between two different projects is the entry point created using the route. And I know that I know that my service always sends it to the correct place. I have a very easy way how to simulate an environment where I have two services running in completely isolated networks, and I can test that the communication actually happens in the way I'm expecting. Okay? Okay. That has been a bit more technical, but it's fine. What is coming in the next version is the network policy, which will allow you to actually say this specific container can communicate with this specific container, but any other container cannot do that, right? So I can specifically say who can communicate with whom and in which direction. So this is going to be cool, but it's not yet there, but it's coming. So let's move to the things that you will probably be more interested in, and that's building and deploying applications. So, sorry. What is possible to do is to deploy applications either from source code, from a binary file, or from a container image. If I'm using Kubernetes, I can do the last one. I can build my container. I have a Docker file. I build my container. I push it to Docker Hub or somewhere, some registry, and then I can deploy it. That's it, right? But we add the other two features. So if you have already some pipeline, you have Jenkins, TeamCity, or something in place, you can build your WAR file, your ER file, something, whatever you're using that pipeline, and then you can tell OpenShift, build me a container that is using this WAR file and is configured for running Wildfly or something like that. So I can move the build of the container inside the platform, and I can have something produce my binary artifacts that I will be just placing into the containers using the platform. However, if you want to take it one more step, you can actually say, build me a container from my source code. And we have something called S2I, which I will be speaking about, which allows you to say, I have my source code. I use this image to build me a new image, essentially, I have my source code for Java application, use this image for building Java applications using Maven, and I will get a new container that will have Wildfly or something, JBoss EAP, Glassfish, something. It will get the result of the process, the build process, which will be the WAR file or ER file, and it will all happen inside the platform. That's what your guy is going to show you during his demo. One more step.
Sure.
So the other thing is I can change my, my development a bit. OpenShift can be easily deployed locally, so I can have a local deployment running on my machine using something called Minishift. If you are familiar with Minikube, it's very similar. It's a tool that connects to your hypervisor. It creates a single VM on your machine, and it places the whole cluster inside that VM. So you have single node, all-in-one cluster running on your machine. With Java, you need a bit more memory, but if you're doing something like Python or Ruby, you can easily do with 2 GB VMs and run the whole process with that. It's quite easy. So what I can do is like I can think of my project, I can bootstrap my project, and I start developing, and I can test locally using containers, using the platform directly on my machine. I can verify everything's okay. I can build the containers inside the platform. And then when I'm okay with that, I can git push, and I can trigger a pipeline in OpenShift or somewhere, and I can build my container inside the platform that can then go through some validations, testing, etc. So I can actually have the very similar, or actually the same environment running on my machine as will be in the production, because the container will be pretty much reproducible between these different environments, just based on the input of the source code and the builder image. So the source to image, how it works is I have a developer, he creates a code, puts it into Git repository, and then I trigger the build itself. So the S2I builder will figure out what is the image. The image is very easy. It requires you to have actually 2 shell scripts or 2 executables inside a container, which is assemble, that's the build process, and there is a run, which is the startup process, how to boot up the application. And then you can have everything, like you can build a container for building COBOL or something, if you want to. So from image registry, we pull one of those containers that are configured for building that particular technology, and then it runs the build process. When the build process finishes, it configures the container to be able to boot up, and the run script is set as an entry point for that container. So when I spin up the container, I actually spin up the application using the run script, and this is pushed again into the registry. And when I have a deployment hook configured to monitor some kind of namespace in registry, I can automatically trigger the deployment, etc. But that's other step. I will end up with the image registry. So for example, Wildfly S2I image, what happens is we pull the source code, we run Maven build with the profile OpenShift. When the WAR file, ER file, jar file is produced, it's moved into the deployments directory of the Wildfly, and then we run Wildfly standalone to spin up the application server itself. If you use JBoss EAP, which is the container platform, the product, we have integration with OpenShift. So essentially, if you spin up one instance of application like that, it will be a standalone JBoss. However, as you start scaling the application, it will start configuring cluster for you. So it will build something like a domain, if I understand it correctly, and it will automatically do everything for you. So you can start with container and then scale up into the cluster just by clicking buttons in the web interface. And now, Jirka is going to show you something how to do this in practice.
Thank you, Marek. So, I will do a very quick demo. There are 3 ideas behind the demo. First, to show you this process in practice. So basically what I'm going to do, and it's not going to be, all the steps are not going to be clearly visible because obviously it's automated. So I will do a demo with our Fuse integration services as an integration platform. So I'm going to take some logic, like integration logic from Git. I'm going to build the image, which is, because it's Java, it's going to involve a lot of Maven stuff, right? So this is going to build the image which contains jars from Maven. It contains the integration logic, which is somewhere, which is the code, which is the logic itself. And all the underlying stuff, including the things which are necessary for run this integration service. And I'm going to end up with a kind of like service which exposes a REST API. And this is going to be deployed in OpenShift, right? So the idea is to a little bit actually demonstrate this one. Second one, introduce very quickly what kind of integration platform we have. And third, and it's quite nice, I'm going to run this entire stuff in a browser because we have a nice like learning interface, something which you can access without registration, without anything. You can actually spin up your own OpenShift and do something in it, right? So it's just the URL I will show you at the end, something you can use at home. So basically I will demonstrate something you can run at home or run at your laptop in a browser and just like demonstrate how it works. So let me switch to this one. I want to make sure, can you guys in the really back, can you see the letters in here? Raise the hand if you can't. Raise your hand if you can't. Okay, the two at the very end can't. So let me try to better? It's good? Right. So this is our learn thing we just introduced with OpenShift. Is as I said, it's a very simple thing. So it all runs in browser. You just access the URL, and what you actually get is the console for OpenShift. And there is a kind of assignment or actually kind of like workshop you can go through, contains a couple of steps. This one is particularly focused on views. I will try to refresh it because you have like 60 minutes when the environment is alive because it's just in browser session. So every 60 minutes it actually dies. So you have 60 minutes to complete this exercise. Looks like it works. Hope it's going to work. It worked yesterday in the bar, so it should work today as well. So this is the fifth scenario. So I have my console from OpenShift. As Marek most probably mentioned, you can access OpenShift via console or the web interface. So this is the console with OpenShift. So what I'm going to do, I'm going to use this command. So basically, I log in as the developer user. I can create a new project. So I will basically create a new project, which is called Fuse Lab, which is going to happen hopefully. Right. So the project is created. And I can create new apps which are going to be part of the project. The project is kind of namespace where the apps actually live. So let me continue to the next step. Okay, the second one. So this is a bit longer one. Something I'm going to use to create a new app. How do I create a new app? I basically define a URL of the Git repo with the YAML, right? So the YAML contains a template. It's a kind of recipe how this actually should be built. So how should, it creates all the necessary artifacts in OpenShift which are needed for being able to run my service, right? So I just click it. So, oops.
You already did.
Failed.
No, it's fine. You did it already before, so when you do it again, it already
exists. I just clicked it twice.
Yeah.
Right. So, I did it before, right here. So what happened? I created a route. That's the way how I'm going to access the service. I created the service itself. I created definition which images are going to be used, and build config and deployment config. These are the things which are necessary, which define how the whole thing is going to be built and deployed later, right? Okay. So I'm good. And next step, I'm going to start the build itself. Right? So I click OC start build and it starts building the actual service, right? I can actually log in my web interface just to have a look what happens here, right? So this is the very similar view, my project Fuse Lab. I'm going to look into it. I see there is this build happening, right? I open it and let me check, sorry, I was just like, okay. I open it, I see the build is happening. So it actually spins up the container where the whole thing is being built, right? So as you can see down here, maybe I will just open the logs in the console, because that's kind of good practice, right? So what's happening now, as you can see, we're downloading the internet because it runs Maven, right? So we need all the jars which are needed for my service. This is going to take like 2 minutes before all these dependencies get downloaded. So let me use this opportunity to explain what Fuse actually is, right? Who knows Fuse? Good. Who knows Camel? Camel should be better. Right. So Fuse, of course, Fuse is our integration platform. In case of OpenShift, we call it Fuse Integration Services, but contains very much the same technologies as the original Fuse. It's based on Camel. So the actual, the most important part where you actually build the integration logic is Camel. Camel is it's kind of like open de facto standard for integration in the open source world, I would say. It's a kind of framework where you can define your integration patterns, you can define transformation. So basically very simply explained what Camel does, you say something like, from my REST service to a database with this address, right? You use a DSL to define something like this, or you can use the graphical editor. What happens anytime that there is a put on this REST web server, like this REST service, a record is going to be propagated, or like it's going to be stored in the database, and you can define transformations and all these kind of things. So this is what Camel does, right? We use, of course, the Camel is a Java thing, so it needs a container. So we run Camel in EAP or Karaf or Spring Boot, right? And because if you run your say integration cluster, you need kind of messaging. We use MQ for that. So MQ is the messaging part. So these are the important things, right? Normally, when it's being run on-prem, we use Karaf and Fabric to actually manage the deployments and stuff. If this runs in containers and it runs on OpenShift, which is this case, the case when we call it Fuse Integration Services, then we actually let OpenShift to manage the whole thing. So the OpenShift is responsible for actually deploying the integration logic and clustering it and make sure it's HA, etc. Right? So that's being done on a container level, which actually simplifies the whole thing a lot. So briefly about Fuse Integration Services. Let's look what happened here. Right. So what happened? My image was successfully built, right? So I got all the dependencies, the Maven dependencies. I built the image, which contains Java, a container. As I showed here, there's the container. In this case, it's Spring Boot. It contains all the necessary dependencies which are related to my RESTful service. It contains the integration logic, a KML route which says from my REST service to a different endpoint, right? So the image is done and it's successfully uploaded to the repository, and hopefully there should be a pod running as well, because as I started the build, it actually creates the pod as well, right? So this is the pod containing the service and actually where Fuse is running. I can open it. I see it's a pod, it's running, it has an IP address, right? There is this image which is built from. It actually has a kind of readiness of liveness probe, because I want to make sure, I want to define how do I make sure that the container is running and ready, right? So in this case, I say my liveness probe is that there is a service running on certain port, right? In this case. So, okay, so I went mostly through all these steps. So that already happened, that's good. So what I do now, I will open the console, which is a console of Fuse, where I can actually see all these routes and the integration logic. So let's open it. As you see, I'm going through the tutorial at the same time because there is usual stuff you can do there. So it's opening the Fuse console. Okay. So once it loads, we'll see. Slower than yesterday. In bar, they have obviously faster connection than here. So I will try to open something like route diagram. Hope it's going to open. Yeah, I did. So the route diagram defines just what I said. Like now it's bigger, so I cannot see very clearly. Okay, so this is what I said. From the REST, if I get a get for user and there is user ID, I will execute this route, which means I will return a identificator of the user, right? That's exactly what I'm going to do. So, okay, let me go back here. Right, so let's go to the terminal, and I'm going to curl this URL where the service is actually running. So, let me do this. So, okay, so what I did a query where I said, give me service /user/123, which is the user identificator, and it returns, okay, this is the user. I can do a couple of other stuff as well. So, by the way, if I go to my console and I open the console again, I actually see that the certain route was actually used, right? So if I look, this user ID route was actually used. There was a certain time it took to process it. And if I look at the route diagram, I see that this one was actually used, and the bean, because actually the user is actually being, I mean, like the reply goes via bean. I see there was one query, and I got a kind of reply. So I can get another users like Donald Duck and these guys. I can do also like find all method. So actually it's a classic microservice which returns a JSON which contains records, right? Of course I can do also something like a create a actually user. So I can do like put. So I can do, okay, let me create let's say user Christine, because Christine, that's her demo, so she should get her credit as well. And yeah, and that's it. So this is kind of the very simple microservice which I've created. I've created it so that actually I used Fuse to define there is this RESTful service which contains records with user, and I let the Fuse to wrap kind of bean actually and create this kind of RESTful service. So last and important thing, usually when it comes to my services, what people ask is a Swagger. So of course Fuse generates something like the Swagger documentation for my service. So what I can do here is, sorry I make it smaller because, okay. So I can do here, I can actually list my Swagger documentation for my service, and I can see it's a classic RESTful thing which contains a certain structure. There are methods and everything is documented by Swagger. So, okay, that's mainly it. So that's how the actual demo look like. You can try it yourself. You just go to, just a second, I lost my cursor. Oops, cannot switch. Okay, now. So you can actually go to this URL and you can try it yourself. There are many other things. You can build your application. I think you can build application with the database, etc. There's a couple of other things you can try with OpenShift. Always is just you open the browser, it spins up the console, spins up the actual web interface. You go through a couple of steps, you execute commands, you do something, you build your application. It's very nice to try, very nice to play with. Before I hand this back to Marek, let me mention that what I've shown, like the way how this integration thing was built, the way how I built this service, is a very similar approach which we use with the rest of the JBoss middleware. So the same way as I build the integration route, kind of integration logic, I can, for example, build a business rule, business process, right? For messaging, if I have a messaging setup, that's very much the same thing, right? So this is generally the approach I can actually build a backend for mobile applications, etc. Right? So it's very much the same approach we use with all the middleware. So this is the way how you can actually very simply take your artifact, something you develop, doesn't matter if it's the integration route, if it's a business process or business rule, give it to OpenShift in a Git and say, like, build me the entire thing for, build the entire thing for me, right? So, good. I think I'm good. So, Marek?
Okay, thank you. Thank you for the demo. It was great. I think I can hear myself, so that's good. So there is way more things that you can deploy on OpenShift, and it doesn't have to be only Java. You can deploy Ruby, Python, Perl, whatever language you are comfortable with. And all of them do follow pretty much the same workflow. You just say, this is my Git repo, they build me a container, and then deploy me the container, and that's it. So the same workflow, and all these things can run for you. And like this is just a small subset, right? You can also go to Docker Hub and essentially take any Docker image that's there and run it yourself. The only problem is that on Docker Hub, most of the containers require you to run as root. We, by default, disable the ability to run as root because it's not safe. And so if you are building your own container, this is like a good practice. Always try to switch the effective user when you spin up the container to some normal user rather than being a root. And unfortunately, if you want to run most of the containers on Docker Hub, you need to lower the security settings we have in OpenShift, right? In Kube, it's okay. In OpenShift, we put the security a bit higher. So if you want to, for example, I think run Tomcat directly from Docker Hub, you would need to say, I am okay with this platform running container that run as root. That's essentially it. I'm just right arrow?
Yeah, it should be.
Okay, good. Okay, good. So on the other hand, you can deploy also many other things, and we separate these two things into two different groups, and it's what we support and what we test and verify, right? So if you want to run Spring Boot, if you want to write things from Netflix OSS, just test it and verify it. So we made sure that it works, actually. But if you want to run something that we will be supporting you with as a company, then there are some other technologies. So for reactive stuff, Epix Vertex, there has been several talks here around it. Wildflies for Microservices, JBoss, etc., and whatever you need. And as I mentioned, microservices already. Have you heard about Istio? Okay, have you heard about microservices? Okay, so there are some. Istio is a framework that should help you with doing like running microservices and simplify things for you. It's something like Netflix OSS. Everybody's familiar with Netflix OSS, right? No? Really? At Devoxx? Okay. Netflix has been one of the biggest popularizers of microservices, right? So they built a lot of stuff for running microservices in their environments. They open sourced these projects. There's a circuit breaker, there is a deployment tool, there is a logging tool, there is a monitoring tool. There's a lot of tools that you can utilize. So these things do a lot of things for you, but they are essentially, they move the problem into the user space. So you as an engineer, you need to understand all those tools, you need to manage them, you need to configure them, and they live as part of your application. Istio is trying to do it a slightly different way. It tries to move all these things that you have to do, but put them on the infrastructure level. So essentially, circuit breaking. Like if I am calling application A calls application B calls application C calls application D, which is completely normal in microservices world. What if one of those calls fails? All of them has to fail, and somebody has to make sure that it's failing, or do some redirection, like say this application is not healthy anymore, redeploy me the container, do all those things. So this is something that can be done on the infrastructure level, doesn't have to be on the application user level. So this is the things that you usually have to do or handle when you are doing microservices. You need to have the visibility and reporting. You have to see what's failing to be able to keep the applications healthy, to keep the ecosystem healthy. You need to be resilient, tolerant. You need to set up routing and control the traffic, because only some services should be able to call some other services. You need to make sure there is some authorization, there are identity of the services, you control who is calling who, what data has been processed between different endpoints. And essentially all these things are implemented using Istio. So what is the goal of the project is to essentially implement all this and put it directly into the platform. So usually you would have application calling a service, sending the data to some other application, and the application would be responsible for checking its health state, checking that everything's fine, reacting to problems, etc. If you deploy Istio, you essentially, the whole data plane, the whole communications thing is put into the infrastructure. So you don't call a service of, service A doesn't call service B. You call, service A calls Istio, which somehow redirects the communication to the service B based on identity, security, based on the profiles, and routing. So all of this is handled by the platform, and your application can be pretty dumb in this regard. And the platform is handling all these things for you, and you are just the operator of the platform. Make sense? So this is something that's coming that will be available in foreseeable future, hopefully. Even in the Kubernetes level, it's still 0. something release, so it's like very much in development. But it's something pretty cool because with Istio, the goal is let people not to bother themselves with so much with distributed system as they have to when you are building microservices architectures. And the last part is logging and metrics. So by default, or usually what we see is that developers don't have access to those information. So you build your application, you give it to operations, and you have no insight into what's happening in the runtime, right? So with OpenShift, again, we have some integration with for logging and for metrics. Logging gives you all the logging. That's what Jiří showed. That was directly in the platform. But if you want to put it on another level, we use FluentD to stream all the logs from the nodes, from the containers, what is being produced. There is another thing. If you are building containers, you should always default to using std out as the logging endpoint, right? Because it's very easy to scrape for all the other integration systems. If you are logging to files, it's more difficult to extract the logs from the containers. If you are logging to std out, it's very easy to scrape and send somewhere else. So that's what we do. We send all the logs to Elasticsearch, and then as part of the platform is Kibana, which you can use to query all these logs, and essentially you can query all the projects that you have access to. So you can do correlations between log messages between different projects if you have access to those projects, right? So you can do all of analysis, what's happening there, and what might be the potential problem of your application. On the metric side, we use Heapster to scrape the information, then it's sent to Hawker, which is our aggregation system. All the information is being stored in Cassandra, and then we exposed all the information into different ways to the user. And all of these things actually run as containers on the platform. So if you deploy the logging, if you deploy the metrics, it will be running as a container on top of the platform. As Jiří used the entry point, there was a URL. So the router is actually a container running HA proxy directly on the platform. So everything that's possible, we try to dogfood and put direct on the platform. So it's managed by Kubernetes, by OpenShift, and it's highly available and resilient. So this is the metrics, what it looks like when you have it deployed. You actually see how much memory, how much CPU, and how much network is being used in the pods, and then you have charts, what is the development. So if you have a problem with memory, you should be able to see that my memory is growing and it's directly integrated in the platform, so I can easily identify there is a memory leak or something like it in my application. And that's it. Thank you for coming. I know it was 9 a.m. in the morning after the party, so that's challenging. Though, if you have any questions, feel free to ask, and we will be. If you are shy to ask over here, we will be here. So feel free to come to us, and we will be super happy to answer your questions as well. And I would like to thank Jiří as well for joining me today.
Thank you. And the last thing I would like to add, try. Okay, it already disappeared. Try the learn.openshift.com. What? It's coming again. Oh yeah, it's going great. So try the learn.openshift.com. You can try a lot of stuff just from your browser. So I definitely recommend to play with it. Thank you.